this error was coming. Let me double check.
No, it's like the linker, yeah, it will munch the symbols and just go across. The problem is the macros won't necessarily be calling it right there. And because it uses so much preprocessing instead of, like it doesn't, a lot of things in SSL are macros instead of functions. And those macros don't do something. It's always been, it's a trade-off. It's much faster because they actually write a bunch of the stuff directly to the code. It's,
so you think it's on the macro or what's
I don't think that's actually true, but it is possible. We did version on it's versioning is not exactly accurate. It's more like the symbols are punched to have a prefix, and sort of like C++ symbols.
but that's the typical so this is a common problem on the C side of the development. Basically, you have the so this is R, and like one of the symbols are there. But you look at
I think I'm going to get started.
Oh, no, that doesn't matter. The version on the S doesn't matter.
Has everybody had a chance to get lunch, get something to eat? Okay. We're going to get started. So, first thing I wanted to, well, my name is Brett Estrade. I know y'all know me, but for the video. The first thing I want to mention is that I created this talk almost 10 years ago when I was at LSU, and it was meant for teaching freshmen coming into the computer science program. So to them, it was advanced Unix. For most of you, it's probably just an overview. Unless you've never really gotten comfortable or played with the command line, then it's probably a good introduction for you. So I wish I had not continued the name Advanced Unix, but I also don't have the source slides. This is the PDF, and I didn't feel like recreating it. And it, unless otherwise noted, this is my content, so LSU really can't lay any kind of claim on this thing. Okay, so the first thing I wanted to mention is that when I first got started with Unix, it was FreeBSD and Sun, and I really went to FreeBSD after trying Linux. This was back in the late 90s because I was too dumb for it. It was a little too hard. FreeBSD provided much more of a easy path for me. But then I got a job working strictly with Sun machines as a user. I was not a Sun admin, but I worked with what I was doing with my day job. It was literally just sitting in front of a Sun machine or accessing Sun machines, and then eventually that turned into Linux. But in order for me to do my job, I had to quickly learn and get comfortable with the command line and just with the basic Unix environment. So that's also when I started using Perl, because Perl made a lot of the stuff I was doing easier, and I was able to replace a lot of the stuff for the people I was working for, rather than using a Fortran program to process text. We could do what they wanted to do with a Perl one-liner. So it was a very enlightening period for me to see how powerful Unix could be. So in order to really master computers and really feel like you have control over it rather than it controlling you or you having to conform to the GUI or whatever you're presented with, you really need to be comfortable with the command line and kind of embrace it and understand what the tools are giving you. The Unix learning curve, and when I say Unix, I mean any Linux, FreeBSD, anything that provides that kind of user interface. It's steep. I found it was very steep, but I'm pretty hard-headed, and I just kept plugging away at it, and one day it kind of just made sense to me. And then after that, it wasn't easy, but it was easier, and I was able to start putting pieces together to do things that I didn't think I could do. And it's fun, it's powerful and enabling, and I think most of you guys would agree. And if you don't know enough Unix to agree, if you just stay with it and are persistent, I think you will ultimately agree to that. Okay, a little bit about operating systems. The operating system is the program that controls all the other programs on your computer. These days with virtual machines, it's kind of clouded as to what the operating system is, but at the time of writing this, I think Box was available, BOCHS. That was really the only virtualization that you would have on x86, but most people didn't use it, and you really were dealing with an actual operating system on the bare metal machine. So that's what we're talking about. It controls the programs that are running. It controls the allocation of computing resources, so the computer processes, the memory that each process is allocated, the security of the system, the networking, and implements basically all the communication between the user and the computer and whatever network you might have, and also the components and peripherals, the mouse, monitor, all of that good stuff. So operating systems are meant to make the computer usable, and there's been a lot of progression over the years from having these mainframes where you have to manually flip switches to the kind of operating systems that we're dealing with today. And everybody loves their Macs. Some people like Windows. Everybody loves their Linux. All of that, the total experience that you get from those was definitely not what you originally got. And this, we're kind of living in a nice time where we don't have to worry about the bare metal and dealing with ones and zeros like they used to. And this is just an operating system breakdown, process management, main memory management, file management, I/O system management, secondary storage, so like USB drives or whatever, networking, protection, and security systems. That's pretty much what I just covered. All right, brief history of Unix. I'm not going to go over all of this, but it's been around for a long time, and it was a kind of a response to industry efforts to have like this one operating system to rule them all. And instead of it's kind of like the 60s. There's counterculture, and the guys who created this wanted to just do something radically different. And it came about through a variety of interactions and ideas, and pretty much embodied, I guess, what we would consider the 60s these days, just the counterculture. But this is a really good book. Y'all can flip through it. I don't lend books out anymore because frankly, I forget who I lend them out to. So
what's the title for the audience?
Oh, sorry. The title is A Quarter Century of Unix, and I think nowadays we're pushing into the 40-year mark. So this book's a little outdated, but it gives a really interesting account of Unix and its origins and the people that had a lot to do with it. There's some pictures in there. It's really interesting. So I can pass this down if you guys want to just kind of look at it. So the history is there. It's been around for a long time. Obviously, its influence has been great, and we're benefiting from it today. I don't know if cPanel would even be around if this whole influence of Unix hasn't been as great as it is. Understanding the history of Unix also can explain a lot of things about the system, about the tools, about how things are named. And I mean, I could probably I'd have to do research because I'm no historian, but we could probably give several talks on the history of Unix. But there's also resources online and books, really good books like that. This is the influence of Unix. This chart is from Wikipedia. It stopped in 2008 because I put this together in about 2008, 2009. But basically from the first origins of Unix, it has influenced anything from, we've got Mac OS, FreeBSD, different BSDs. Linux is not on here, but, oh, here it is. But it's not connected directly. Linux, as you guys probably know, is a Unix workalike, and I guess, when was it? In the early 2000s, there was that whole SCO Unix versus Linux lawsuits that were happening, and the BSD went through a similar lawsuit attack with, when they were, I'm trying to think when it actually was, but basically the BSD forked directly off of the original Unix tree. Linux was basically a Unix clone. BSD was greatly impacted by, I think it was AT&T, trying to sue the bejesus out of them. And then Linux kind of went through its own lawsuit happy attack from SCO in the early 2000s. So anyway, there's lots of intellectual property that people used to like to protect with Unix, and now we've kind of settled upon the free Unixes, and then there's still some paid Unixes, but usually people just go for Linux or one of the BSDs. Okay, so this is getting more into the architecture of Unix as an operating system. So you can think of it, if we want to start in the middle here, there's the hardware, okay, and that's like your bare metal. Around it, the operating system provides a kernel. The kernel is the low-level interfaces that will talk directly to the hardware. Okay. Outside of that, most Unixes will provide a system call library, and that allows programmers to conveniently access the hardware, utilize the kernel system calls, and all the great features that are provided. So Linux, FreeBSD, they all have their own system calls. They're not exactly the same, but they have calls that do basically the same things. There's memory management, process management. These days there's encryption that deal with encrypting on disk, communication, there's the networking stack. So all that stuff is kind of contained from inside of the kernel, and the system call gives somebody programming on the system the interface, so they don't have to worry about low-level details. And then outside of the system call interface, there are provided your standard command line utilities. Now Linux is just the kernel, okay? So this is what Linux provides, and then you've got distributions. So you've got Ubuntu, you've got CentOS, Red Hat, Fedora, Arch Linux. Those are distributions. People have taken utilities and kind of slapped them on top of whatever Linux kernel you're using and provided it as a polished product so it's easier for people to use out of the box. FreeBSD is more like it's provided as a complete top to bottom operating system. So in the open source world, it's being provided more as a single unified thing, like say Windows would be, versus Linux, which provides the kernel, and then Linux kind of leaves it up to other people to package the distributions. And another interesting thing to note about Linux is, so there's Richard Stallman. He set out, he's a big open source advocate. He set out to create he's the original creator of the GCC compiler. He originally set out to create a free Unix, okay? So he created his own kernel, which is called Hurd, H-U-R-D, and then he created a bunch of utilities, so the Unix commands and libraries on top of his Hurd kernel. Well, Herd never, I guess it's never really seen the light of day. Oh, this is the same guy that created Unix also. But anyway, Herd hasn't really seen the light of day, but the utilities that he created and the people who are contributing to the open source movement, they created a lot of really nice tools. GCC is just one of them. And they basically created free versions of traditional Unix utilities. Well, when Linux came around, what they decided to do was put the Herd or the GNU userland on top of the Linux kernel, and that's kind of where you got the origination of a usable operating system that was Linux-based. FreeBSD, on the other hand, they have always, or at least always tried to provide their own stuff. They've been going through a huge effort over the last decade to get all the GNU stuff out. They've even, within the last few years, replaced the GCC compiler, and they use, what's the compiler they use?
They use LL?
LLVM, yeah. So that's more of a BSD-friendly compiler. They still support GCC, and they still make sure that the operating system and the tools compile with GCC, but out of the box, it's LLVM. Okay, so command interpreter system. So in this slide, we've got the Unix commands and libraries. That's all good and well, but you still need an interactive system so that provides the user the ability to type commands on the command line, and that's what the command interpreter system is. Now we typically call it the shell, and I think some of the more common shells are like Bash these days. I think some people use Z shell, K shell, Corn shell was from IBM. I don't know if anybody still really uses that. C shell, I don't know if I mentioned that. But the gist is, and Windows has a similar thing. If you've ever opened up the command window, you can type your commands and list your files and navigate the file system, run different commands to look at, say, what IP address is assigned to your network interface. Most operating systems have this interactive shell for you to talk to the operating system. So that's what I mean by this here. Commands are given to the operating system through this interactive system, and you, like I said, just like in Windows, in Unix and Linux, you can navigate the file system and call basically any utility, any ready compiled or ready to be interpreted command at the command line. And this is kind of like a breakdown of what the shell is. As I've said before, you've got the hardware, and then you've got the operating system, and then on top of that, you've got the shell utility. Here I've got listed Bash. TC shell is Turbo C shell. It's kind of like another incarnation of C shell, and then KSH is the IBM shell. I use KSH at LSU because we help maintain some P5 and P6 clusters. So the native interface was the shell. Okay. So basically how it works is when you have the command window open, you're basically in a Bash interactive session. Let's just say Bash for now. And you give it a command, and then the command will either execute its own low-level commands to the operating system, or it will run a utility that it has to compile and support through system calls to interact with the operating system. And we talked about last time. If I don't know if everybody was there or if everybody looked at the talk we did last week, but I did a side-by-side comparison of Perl and Bash, and I tried to make them look as similar as possible. Okay, and one of the points I was making then was you can do a lot of stuff. Pretty much you can replicate most basic behavior that Perl provides you in a shell script, and that includes program control flows like if statements, loops, that sort of thing. So shells are basically programming. They provide a programming environment. Not only can you just type commands at the command line, but it gives you a way to literally write a program and then just run that program as kind of like a bash or a script. Okay. So another thing shells provide is an environment. The environment is these variables about your operating conditions that the shell script just has set. And I think everybody kind of understands this conceptually. But when you open up a shell program, or when you open up a terminal, and say you're in Bash, it knows the set of paths to search, so you don't have to write the full path of, say, an executable command. It knows that if you type in, CD, the CD utility is going to be in one of the paths that are on the path variable. Okay. And this is another view of the environment. So you have this global environment of knowledge under which the shells are operating, that the skeleton environment that the system administrator may set up for you. And then you've got your local environment that the user has. You can set up your own environment, your own environmental variables. You can append to your path environment or path variable so that the shell looks in additional directories for utilities that you might have installed locally in your own home directory. And then ultimately, whatever shell you're using will have this knowledge and be able to use it as it's doing your bidding and interacting with the operating system. Okay, here's some examples. These are actual commands that you can issue the command line to look at your environment. env is the actual utility that will report to you what your environment looks like. This is in C shell. Print env is, I think, the C shell. Yes, the C shell. So the green is the command you would issue to see the environment. This in red, you can kind of ignore that, but we're going to talk about that shortly. That's an example of putting two different programs together to make doing what you want to do a little easier. More in this case is a pager. If you have a lot of variables and it goes past the screen, you can use that pipe more to kind of steadily page through and be able to look and navigate this big dump of text that you're looking at. And there's more than one way to do it. In C shell, there's print env var name, and then you could also just use echo $var name. That's the shell variable with the $sign in front. Okay, these are some notable environmental variables. Home, of course, is your home directory. It's where you land when you first log in. That's where you keep all of your stuff. Path is a delimited list of directories that the shell or interpreter will use to search for executable utilities. Rather than you having to type in the full path every time, it's just a convenience for you. I have these in here because at the time we were doing lots of compiling of things. But LD library path is a way to tell the compiler where to look. Like say you compile some custom libraries, and instead of using the standard libraries on the operating system, you want to look somewhere else. You would use these variables to impact that.
Yeah, didn't that cost trouble?
I'm sure it did. Library path is like where your compile libraries are. The include path is where you would look for your header files, like in C, the .h files. So, just in case you want to know. This is when I really cared about not using C shell. When I first started writing shell scripts, I wrote in C shell, and I kept banging my head up against the desk, and then I discovered Bourne shell, and then Born Again shell, which is modern Bash shell, and things were a lot easier. And then, of course, I discovered Perl, and then, but I still write a lot of shell scripts.
Is there a Perl shell?
There is a Perl shell, yes. I've played with it, but I don't use it for anything advanced enough to really.
You can always do Perl -e read while eval.
Yeah, exactly. Yep, that's true. Okay, manipulating the environment. In Bash, so if you wanted to set an environmental variable that is persistent throughout your terminal session, you can use the export command. In C shell, it's set env. This is just an example. So you just do export, whatever your variable name is, and then value. C shell is the example in red. And again, this will persist for the entirety of your interactive session. When you close out the shell or the terminal, they don't persist, they go away. Okay, this is just another way if you want to augment path. So if you install something or have an executable program or script, and you want to include that, like you could write a Perl script. You could write a Perl script, name it CD, make it executable, and then add your path to that executable Perl script called CD in front of your path. And then when next time you call CD, it's going to call your CD and not the actual CD. And in fact, that's the source of a lot of exploits. So, yes. Okay, creating a custom environment. So I mentioned that if you use the export or set env in C shell, the global variable you set will go away after you kill the interactive session. You can create your own environment that is available any time you log in or you open up a shell. And in Bourne shell, okay, so I say Bourne shell here, that's the original Bourne shell, so sh rather than bash. I think on most Linux systems, sh actually links to bash, but on BSD, it's the actual modern incarnation of the Bourne shell. You have to install bash after the fact of BSDs. So etc/profile gives the system administrator at cshell.cshrc gives the administrator like a global way to set profiles for anybody that are using these shells. And then if you yourself want to control your own environment, you've got a lot of options here. So for bash, you've got dot bash, and we call these dot files. This tilde right here references your home directory. So you got dot bash _ profile. This is run. I'm assuming this is all true again. This is about 10 years ago. This is looked at by your shell after the etc profile is loaded. Okay, if it exists. Now dot bash rc is referred to as a resource file. That's run after the dot bash _ profile. Okay, and then dot profile is run after that. So you've got the system for bash. You've got /etc profile, then you've got your local dot files you can run that are taken in order, and each one can overwrite the other. Here. Normally, I kind of go between using the dot bash rc and dot profile. I've never really settled on anyone in particular, but I don't think I've ever created dot bash _ profile. And now there's also another dot file that gets sourced when you log out. That's dot bash _ logout. When I first went to college, this was in 1995. I had a friend who had been there for a couple of years, and this is back when email addresses were new. We were still using Telnet to get into Pine to check email. So when he until I learned about the dot bash logout dot file, I had no idea how he did this, but he was showing off his Unix skills and was like, hey, check this out. And he would log out, and it printed out see you later and an expletive face, like he liked to curse himself out, I guess. But anyway, it was pretty funny and interesting, and I never figured out how he did it until I saw this. But basically what he had done was he created a dot bash logout file that echoed out a message whenever he logged out. But you don't have to just echo out a message. I mean, these are actual shell scripts. So most people use them to set your local environment on a dot bash logout. You might use that to clean out a local temp file or delete your mail or do something that some kind of repetitive thing that you want to do every time you log out. Huh?
Turn off the oven.
Turn off what?
Turn off the oven and lock the door.
Oh yeah, exactly. That's for NetBSD. NetBSD it's meant to be an ultra portable BSD, and the old joke is that they want that it runs on your toaster or will eventually run on your toaster, and I guess that's not really far off these days. I mean, I wouldn't be surprised if there are models of toasters that are connected to the internet these days, so, or maybe your Nest or something. I don't know.
There are toasters.
Really? Oh, awesome. Okay, so the next thing I want to talk about is the file system. If you're coming from Windows, this is pretty confusing because we're using, I came from Windows. I think the last Windows I used was 98, Windows 98. I played with 2000. I got burned pretty hard one time on a, what was it, email client? Outlook Express. I got burned real hard because I clicked on somebody's link and then it emailed everybody in my address book the same link. And after that, I was just like, I'm just going to use Linux, and then Linux led me to FreeBSD. But anyway, that's why I stopped using Windows. And in any case, in Windows, you're used to C drive, D drive, the letter, colon, and that's all nice and well. It's easy, I guess, for people not familiar with computers to kind of get what's going on there, but it's not really scalable. And the way that Unix does it is it looks at your file system as a tree, and it starts at the root. And the root is, if you ever do like CD// that takes you to the root of the file system. Okay. Now this is all like a virtual representation of the file system. It has nothing to do with the physical representation, which is what Windows was giving you. It was showing you that you had 5 drives, and it was like C, D, E, F, G, H, whatever. Here, when you're navigating the file system in Unix, you don't get that device-based representation. You get this unified version of the file system, so that dev, of course, is your list of drivers, but /user might be rooted on one disk, but it may also contain other disks that contribute to the space that's under user. Var, temp, etc, mount, all of these may be connected to any number of devices and partitions to give you just this field of storage that you don't have to worry about. Oh well, users on there's no correlation between C drive and /dev or /user and D drive or anything like that. Okay. This is just a typical top-level directory layout. Slash is a root partition. There's only one. /dev, like I said, that's all of your devices, system devices. Unix, Linux, BSD, they all represent any number of things as a device. And that's just a common programming interface that they provide, so it's easier to write drivers for these things. Dev0, if you say cat dev0, it's just going to give you an endless stream of zeros. Urandom is a pseudo-random string. When you see stuff like /dev and an ADSO1A, that's like a partition on an actual disk. So user, typically that's where users go. I'm sorry, that's not true. Okay, user is where your user utilities go. So there's user bin, user lib, user home. Home is where users typically go. Var is for like databases and data caches and stuff like that are more or less persistent. Temp is for temporary data. Etc is for your system settings. Mount is not a standard thing. A lot of people will use mount or opt to put in, if you want to add additional devices, you can throw it under opt. Or if you want to start installing like your own versions of common utilities or already provided utilities, you can throw them into opt. All right, this is just a visual of how the directory, the file system is viewed as a tree. That you then get direct ways to reference specific parts in this tree, and that's called the path. So the directory path is really just a path in the tree, an unambiguous path to somewhere. So this user home, user 5, it's starting at root, you go into the user, you go into home, and then you go into user 5. So it's a very logical, efficient structure and way to view the file system. This is just a list of different file types. you've got a typical regular file, which is it's just ones and zeros. I mean, it's just data. It can be taken as ASCII or a PDF or I don't know, a zip file or PDF or something. But it's just treated as a stream of bytes. A directory is where you would put additional or you would put files. So it's basically a container for files. Let's see. Special contains no data but serves as a mapping to a physical device. So that's kind of like what you would see in dev. Okay. Named pipe. This is a way for the operating system can track a file. Let's call it a file or a named thing that can then be used for two programs to communicate with one another. This is called IPC or inter-process communication. They're very neat. I'm not going to talk much about them, but basically you can create a named pipe, and then in one terminal window, cat some file to the named pipe, and then in another terminal window, you can redirect the named pipe into something else, into a file, and it will basically the information that you're catting into the named pipe will then come out on the other end, and you can do something with it. So it's a way to link different processes. An actual link is an alias for a file that's used a lot. A symbolic link is it's another way to link files. I don't really know the difference between the two, but I know they exist. Plus, that's a little too much for us to go into anyway. All right, navigating the file system. So in Windows, you would use the dir command to list files. In Linux or Unix, ls is the command. And then you've got flags, so ls minus, I don't know if that's a 1 or an L. Okay. So minus L will sort your listing in order, I think, of the newest to the oldest. I usually do ls-lart, and that just lists my files, so I see the most recently changed files at the bottom. You don't need to know that. PWD, it'll show you where you are. Okay, the PWD stands for present working directory, and it gives you an absolute path. So that's starting with the slash, going all the way to exactly where you are. You can move into a directory with CD. So I mentioned if you wanted to create your own CD and put the path to it in front of the path environmental variable, you could and use that, but I wouldn't really recommend that. Okay, so the dot is a relative path, a way to reference relative path. So if I do dot means one level above. I don't have a really good graphic here, but to show this. But if you were sitting here in user 5 and you did cd dot, you would just jump one level up. And those are called relative paths. So using a series of relative paths, you could do dot slash dot slash lib. You could do a dot and jump here, and then do another dot and jump up here, and then slash temp. So you could do cd dot slash temp, and that would jump you up here and then back into there. So it's a way to reference. It's a way to navigate the tree relative to where you are, rather than having the absolute path here. So when you see the dots, dot means where you are now, relative to where you are now. Dot means relative to one level up. It's convenient when you're actually typing the command line, but it's not really good to use in scripts and whatnot. Okay. So that's what cd dot means, move one level up. But you can have dot slash dot. Okay. All right, move directly to your home directory. Tilde is kind of like shorthand for your home directory. You could also do cd $home in all caps. A lot of times you can just do cd, and the default behavior of cd without arguments is to jump into your home directory. Copying and moving files. The copy command on standard Unix copy command is cp. So cp file A, file B. You're copying the contents of file B to a new file called file B. So cp file A, file B. If you want to copy the contents of a file that is one level above you, and then drop it into a new file name where you are. That's when, let's see, you see the dot dot. So you do cp dot dot and then file A, which is above where you are, and then you want to dump the contents in a new file called file B. If you want to copy a full directory, you have to use the -R. By default, cp just assumes that you're copying a single file. If you do cp and a directory name, and then some other directory name that you want to rename it, or you want to have that copy name to, it'll give you an error. So you have to do -R. Here, this is copying everything recursively in directory A to a new directory called directory B. Well, I guess if directory B existed, it would use the existing directory. So when you want to rename something, you're actually moving it, okay? And the move command, there's no rename command, there's only mv. So mv, file A, file B. Now, mv is, maybe I'd like to talk about it in some other presentation, like atomic things you can do on Unix. And these atomic things are things that happen, they either happen or they don't. And you can use them to make sure that you don't have two processes messing with the same file at the same time. But the MV does, if you're in the same, so the file system is a tree, and if you're in a directory, say you're in the same directory, you're going to be on the same physical disk. If you do an MV, file A, file B, it is going to rename that file atomically, meaning that it's from the outside looking into any process. All of a sudden, without warning, file A is just going to disappear, and then file B is going to appear. All right, and it does that by messing with some internal stuff in the file system. It's not actually moving things. Okay, but that's what you would do to rename. Now, if you were moving something across file system boundaries, so like say you wanted to move file A to another directory, but that directory is actually on another physical disk, it's going to have to do a copy. And that is not atomic because it takes time. So that's just something interesting to note about MV. If you're on the same file, same disk, or same partition, it'll happen instantaneously. Otherwise, it's just like a copy. It's like a copy and delete, really. Copy file A over to file B, and when that's done, delete file A. That takes time. And then you can move your whole directories in the same way. And I don't think you have to use -R for MV. Okay, do we have any questions so far? Okay. In last week's talk, when I was comparing Perl and Bash and showing how in Perl it's got the built-in regular expression and string editing stuff, but in the Bash script you need to use the command utilities awk and sed. I made a comment that the typical philosophy in Unix for Unix tools is the tool does a very specific thing and it does it very well. And this is what I'm talking about here. So let's see, do one thing, do it well. Unix has a ton of small, very focused utilities. And I gave some examples leading up to this, but here are some more utilities. We already talked about cd, which is change directory. Cat is short for concatenate. If you do cat file name, it'll just barf the contents of the file to standard out. If it's a text file, you see the text fly by your screen. If it's binary, you'll see all the weird symbols flying by, and it may even mess up your shell. If it gets to right series,
Reset to fix that.
yeah, and then you would type reset to fix that. So if you're playing with cat, and then all of a sudden you see like weird things at your prompt, just type in reset, even though it won't look like reset. Okay. Find is a really handy utility. It'll let you find a file by name, by creation date, by access time. It basically gives you a way to search for files based on any kind of information that can be gotten from the file system itself. File, it tries to identify the type of file you're dealing with. Grep, you can cat the contents of a file into grep and then search for a specific string. It comes with a bunch of handy options, and then it'll find different lines in that stream of text. that you're looking for. So I think everybody here that uses Linux on a regular basis uses grep heavily. Git even has its own grep functionality, so you can search for strings in the whatever files are being maintained and tracked. Head will, if you just want to look at like the first so many lines of a file, you can use head instead of cat. Tail will let you look at the last so many lines of the file. Less is a pager. It's like in the previous slide, we did env pipe more. Less is just another more modern pager. Okay.
Actually, it isn't. It's actually more.
It is more.
It's an alias to more, just with a different option.
That's Joe.
So less is more.
Yeah.
That's awesome. I didn't know that, but that Unix is full of funny little things like that. Okay, touch will either create an empty file for you, or it'll update the access time of the file. WC is the handy one. You can pipe the contents of a file, or cat the contents of a file into WC, and it'll give you statistics like how many characters are in there, how many lines are in there, and then, I don't know, there's another number. But it has options also. You can use that as a handy way to see if a file was updated or changed in some way. It doesn't give you the actual diff, but anyway. So there's lots of different utilities. I mean, there's a ton of them. Everything is a filter. This is another important thing. I keep talking about, you know, catting the contents of one file or piping into another. So the way that you need to think about it, and the way that Unix connects, the Unix philosophy connects utilities is a filter analogy. So cat, whatever my file.txt, this pipe, this straight up and down thing, that is like an input filter. And then, so it's taking whatever cat is spewing out on the left-hand side, and on the right-hand side, is interfacing with grep. Grep knows how to treat the input, and then it's taking all of that input, which is the entire file, as a stream, and it's filtering out the text, and then it's going to report whatever it is you're asking it to report. So the best way to think about connecting utilities on the Unix command line is a filter. There's also another way to dump the contents of a file into a utility like grep would be to do a redirect. And the way that you would do this is you kind of flip it around. It's still a filter analogy, but in this case, the recipient of the output is grep on the left-hand side, and then there's the less than symbol, and that's the input redirect, and then myfile.txt. The shell is actually, rather than using cat, the shell is actually interpreting your intent here, and it is using its own mechanisms to dump the contents of myfile.txt into grep, and then it'll output whatever it is you're looking for. You can also have multiple redirects. So in this example here, you're dumping the contents of myfile.txt. It's going into grep, and in grep, rather than dumping its results to the screen, which is called standard out, it is redirecting all of whatever is in standard out to new file.txt. So if you want to take all instances of hello, or all lines in myfile.txt that have the string hello, and put them in a new file, this is how you would do it. So this greater than is an output redirect, and you can still use it with the input redirect. So here you would have grep, which is receiving the contents of my file through this input redirect. Okay, so that's like one thing, and then the output of this will go into new file.txt. So you can kind of start seeing how things can get linked together. Many utilities can be inline. This is just a example, and it's not even extreme. I mean, people can put together like huge gargantuan programs just by linking together utilities. So there's cat my file, it goes into grep, it gets all lines that say hello, And then say not all the lines also have world, but what this does is you'll get, and this doesn't necessarily guarantee you get hello world next to each other, but the hello and world are somewhere in each line. So you're getting all lines that say hello, and then from that set of lines, you're going to get all lines that say world, and then you're piping it into this pager, so that rather than redirecting it to a file, you have a way to manage looking at it on the screen instead of seeing it all skewed forward. Okay, any questions about this? I'm trying to rush through. But this is really one of the key points. So special utilities that do a very focused thing very well, and that everything is a filter, right? So it either accepts input or it prints out. Okay, accessing input. I don't have an example here. The stream of data that is being accessed as input for a program is referred to as standard in, and then whatever's getting dumped out of the program is referred to as standard out. So these are basically like there's an input channel and an output channel, and that's where the filter analogy comes from. There's also another channel called standard error that does not get into standard in. Like you can, if there was say there was an error here, okay, only stuff using this syntax, because you can redirect standard error into standard in. But using this syntax, you only get the standard in or the matches in this new file.txt. If there were some errors for some reason with this execution, or even with here, it would just be printing the errors to the screen. So you kind of avoid getting errors in this new file.txt, but you should investigate the source of the error because it's probably pointing to a problem you want to fix. Shell programming we talked about last week, but it's just basically writing a program with the shell and with the control structures that it provides you, variables, and then also linking together all of these utilities using the pipes and the redirects. So when not to write a shell script, I'll just say this. If I need to do something, I usually will just write a shell script. If I need to do something, create a tool, and it's easy enough to link the utilities, I'll even link sometimes Perl one-liners inside of a shell script. When I go from, the point at which I go from shell to Perl is when I start needing to use data structures or actually implement, algorithms, loops, and all of that stuff. Or if I need database access. But typically my go-to thing to do most things, like the glue stuff, are shell scripts. I use Perl for more or less for bona fide programs. But everybody's different. I used to say that I go from shell to Perl when I start needing arrays, but last week we discovered that Bash supported arrays, so I still don't want to use them because it's easier in Perl. Okay, this is VI stuff. Who doesn't know how to use VI? Okay. All right. Who uses Emacs? Okay. Rob, what editor do you use?
Command line I use Nano.
Okay, that's fine. VI and Emacs. I mean, this is not. I'm not going to hate on anything. However, what I will say is, using a text editor like VI or Emacs would make you infinitely more productive. So I would encourage anybody to learn either one. I tried learning Emacs before, and I think I'm just too dumb because I just couldn't get it. I had to struggle through it. I took a Java programming class one time, and we had to use Emacs, and I hated it. So, but VI, it requires practice also, and I just took to it a little better. So that's why I use that. Okay, so that's for that VI stuff. So in summary, I like this quote. I think I saw it related to BSD one time, but it said, Unix is user-friendly, it's just picky about its friends. So that kind of like refers to, if you put the time into it and you get past this learning curve, one day it'll just kind of like a light bulb will go off on your head, and you'll be like, why have I not used this before? I mean, it gives you so much power, and then suddenly you realize that being chained to Windows or some of some GUI tools on Mac just kind of shackles you down. And if you were just able to, if you understood Unix philosophy and you could use command line tools, I mean, basically you can do anything you want. It's pretty awesome. And okay, so the shell is the main venue for user interaction, and you need to be aware of what your environment is and how to manipulate it. It makes things easier. And then Unix utilities are small and special purpose, and Unix gives you a way to string them together to do really awesome things. And file system is a rooted tree. There's no C drive, D drive. There's no actual analogy to the physical devices that are supporting your storage when you're navigating the Unix file system. And this applies to Linux, BSD, Mac OS nowadays. Windows is really the only one that has the C drive, D drive, all of that. Learn either Emacs or VI. I prefer VI, but your mileage may vary, as they say. And lastly, you can literally take a junk machine, in your garage or at home or something you find in the trash, and put one of the free Unixes on there. I mean, there's like, if I have to pay, in my personal life, if I have to pay more than $25 for a computer, I feel like I got ripped off, because I'm just going to throw FreeBSD or Linux on it. And anyway, or I just wait till they give away stuff here. Okay, and that's it. Yeah, I put this together. Estrade is I forget where he's at now, but he helped me with this at LSU. He's a PhD student at the time. So we were doing a tutorial for freshmen coming into computer science, and this was just one part of it. I also have there's a lab that I would like to give at one lunch and learn, and basically it would just require you to come with a computer. And this is really for people who haven't really ever done Linux before and you want to get your hands dirty. So I don't recommend it for most people in this room, but if you want to start getting dirty with the command line, it gives you basically just a rundown of things that you do, and it'll probably take about an hour. And I can present it here really anytime and just be here for help if interested. And that's it. Any questions?